Hello, I hope the first video helped you understand the very basics of R and R Studio. Again, if you have any questions, please don't hesitate to reach out. I just wanted to cover a couple of questions that were asked by some students regarding the first video. And the first thing I want to say is that when you're working in R Studio, as a general rule of thumb, double or single quotes are actually equivalent. So if you want to use, for example, quotes when importing a CSV file, you can do read.csv, and within that you can either use a double or single quote around the file name, and either will work. The same goes for strings. When you are saving a string, you can say new string equals hello policy 610, and this can also have either double or single quotes, and it will work. The other thing I wanted to mention that I did not in the first video is that you can always open new windows to write new code without worrying about deleting or altering maybe what I wrote. So if you want to do that, you can just go up here to either File, New File, and RScript, or you can click on this top left button here and just click RScript, and then you will have just a completely new tab open, and you can just highlight everything and put it in there if you are interested in replicating what I do, or making different versions of what I do, or even making different versions of your own code when you run that. So I just wanted to mention those two things. Before I get into today's discussion, which will cover the commands necessary to complete problem set number 1, I want to just briefly review some of the functions that we used in the first video. So let's just go ahead and import this vote.csv file that we had from last time, that we used last time, excuse me, and let's do read.csv. Again, double or single quotes are okay. Vote.csv is the name of the file because it's in the same folder that we're working in, and if we run that, then we see that it ran in the console below. But always remember, as I mentioned last time, that if you want to save that data, you always need to give that data a name, put an equal sign, and then after the equal sign, put the name of the function. And so when we run that, we will have that data uploaded, as you can see in the top right, and now we can use some of the functions that we used last time. So we named the data frame df. So if we want to look at the first couple rows of that data frame, we just put in head and then brackets, and then in that we put df, and it should run. We were successful. We also have the names function, which is showing the columns of all of the data in the df data frame. So then we have that here, state vote, all the different column names. We also use summary. And exactly like names, we will just put the data frame in the middle of the brackets, run that, it will give us the summary statistics. And then the mean and the standard deviation were a little bit trickier. If you remember, you need to use the function mean, and within that, you don't just put the data frame. You actually have to put, if you did that, you would get an error. You have to put the name of the data frame as well as the column you're specifically interested in looking at. So state, vote, income, education, age, or sex. This will just automatically pop up. It's a really nice feature of RStudio. And then we can get the mean. And then the standard deviation is the exact same way. Say getting the standard deviation for income. And yeah, that basically covers what we did in video 1. And we will also be using a couple of these functions in this video as well. So without further ado, let's hop into the code for today's lesson. This code will be available again, this presentation on the left side will again be available online. Here's the link if you're interested in looking at it to use it as you go through. Now we're going to move on to something new. We are going to import a new external library. In the first lesson, we used functions that were actually just built into the R code, but today we are actually going to use functions that are a part of external libraries. So this library we're going to use today is called dplyr. It's called dplyr, actually I have no idea why it's called dplyr, but what it does do is manipulate our data, and I use it every single time I use R because it's just so helpful. So I wanted to just introduce it to you. If you want to know a little bit more about dplyr, please visit this tutorial that I actually made for class last semester, but I will just go over briefly how you install the library first because that's the most important step before we use it. So in A211, you'll see that I have this function called install.packages. In that function, you're just going to put the name of the library that you want to install. So in our case, it's dplyr, and you will run that line of code. Now below, you will notice that something is happening, right? You see that there's a line in blue, and you see this little stoplight should be highlighted, and that means that R is actually trying to download the package, which is exactly what this says here. Now it's red, but don't be scared. As I said last time, in general, blue is good and red is bad. In this case of downloading packages, though, they use red to just give you some idea of what's happening. And you can generally know whether the download was successful if it says the downloaded source packages are in some folder, which means it was successful. What you don't want to see is an error message. If it says error, that generally means that you did something wrong. Perhaps you didn't put it in quotes, or perhaps you did install.packages incorrectly. Now, the next step that we have to do is actually import that library. So all we did in 2.11 was to download the library. In order to use the functions associated with that library, we also need to just run this function, which is library and then the name of that library. So again, we get some red, but that's not necessarily bad. It doesn't say any error. These are just warning messages. So we're good to go. It looks like it installed, and I can show you how to use that in 1 second. The other way, though, to install it that I just want to mention is that rather than type this install.packages, you can actually go to this tab here called Packages. In the first video, I just showed you this File tab, which shows us what's in our folder, which is important if you want to import data, of course. But if you want to import packages, you can just go to the Packages tab, Install, and then type the name of the package, and then you should be able to download, and it will do the same thing that we did in 2.11. Now we will move on to answering questions from the problem set. So what we are going to do is actually use the dplyr package to answer the question in 1B. Now I will be showing you multiple ways to answer the questions. So if you notice that in question 1.1, I show you how to get the answer from 1.11 by using dplyr, and then in 1.12 we don't use dplyr. So don't panic if you're not comfortable using one of the methods. Either works. It doesn't matter for me. But I wanted to show you both because it's important to know that in R there are many different ways you can do things. There is not usually one right way. So what we want to do is actually create a table of frequencies. So for this example that I give here, I'm using this vote_df data frame that we already imported. This is actually the same data frame we used in assignment 1, except it's just named differently. And what we want to show is the different level of education by how many people are in each education level. So we want to show, for example, how many people have education 2, how many people have education 4. So what we do is say that we write the name of the data frame, we write the name of the data frame, which is vote_df, and then we type in these little kind of strange symbols, which is actually called the pipe operator in R. this is actually part of the dplyr library that we imported. So if for whatever reason this line of code isn't working, it's probably because you did not import dplyr correctly. But it's rather straightforward if you did. What we do is, again, write the name of that data frame. We use the little pipe operator, as it's called, and then we use the function count. And then within that function, we just put the column that we want to count. So in this case, we just want to see all of the different observations for education. So if we run this, what we see here below is exactly what we wanted, a frequency table. So for the education level 1, there's 217 people. In the education 2 bracket, there's 487 people, and so on and so forth. But the cool thing about dplyr is that this can be done for any of the columns. So for example, say we wanted a count of vote or not vote, all we would have to do is, again, name of the data frame, pipe operator, count function, and then we could just change this to vote. And again, we don't need quotes here, so that might be kind of strange because we used quotes last time, but dplyr doesn't need quotes. So if we try to run this line of code, we notice that it also gives us a nice little frequency table here. Now, some of you probably want to save this data as Excel data potentially, and I can show you how to do that right here in 1.11. So we use the exact same type of code as we did last time, but the nice thing about dplyr is that when we want to add on just simply one more line of code, we just add another pipe operator, and then we add that function that we want to use. So I actually wrote it down here in 1.11. We write write.csv, so I'm sure you can imagine what this does. It outputs a CSV file, and this is something that actually you don't really need to be aware of, but it just removes the row names, so it just kind of makes for a cleaner export. And if you were to run this, you'll see blue, so that means generally that it's good. What it did was it actually wrote a new CSV file to our local folder. So we named that CSV file education.csv, and lo and behold, we have that education CSV file here. So when you want to use it to put together your assignment, you can use maybe Excel potentially. And moving on, there's another way to actually do this as well without dplyr, and that's just using the table function. So that's in 1.12, which does the exact same thing. And it's just a table function. And then inside the table function, we put the name of the data frame, which is vote_df, and then we select a certain column like we did for the standard deviation and mean functions, and then we run it. So let's try that. And what you'll see is that we got the same information as dplyr, but it's just kind of presented a little bit differently. And if we wanted to save that information, we could set it equal to any name that we want, and then if we want to show what we just saved, we can just run these two lines of code here. And what you'll see is that there's a new table up here that has been saved. So feel free to use any method. I recommend you use dplyr just because it's so helpful to use if you work with R a lot. And we will move on to 1.2 now. This time we are going to actually create a relative frequency table. And it's quite easy if you have saved your table data already. All you have to do in 1.122 is to use this prop.table function. And inside that, you will actually put that table that you had saved before. And you can just run it, and what you'll notice is that, and let me just clear everything out just to make it a little bit more clear. This table in 1.12 is shown here now in the console because I just ran this line of code. And then if we want to get the proportion percentages, it's just all it's doing is giving us the same exact table, but as a percentage of the total observations. So this 217 is actually equal to 14% of the observations, and so on and so forth. But we can also use dplyr. It's a bit more complicated, which is why I'm showing you it second. And it looks very similar to what we did before, but it just adds on another operator and then uses what's called the mutate function. And the mutate is just to create a new column. And what we want to do here is to show the percentages. So if you run this line of code, what you'll see is each education level, you'll see the number of observations, and you'll see the percentages of observations. Now, this mutate function, I can go into a bit more detail perhaps after the lesson when I talk a little bit more about dplyr for those of you who are interested. This can be, when you're using the mutate function, the first thing you type is exactly like all the other objects that we create. You can name it whatever you want. So it can be called, percent education, but like all of the other objects we created, it cannot have a space. It must be connected. And then you can run it, and you'll see that this column that we created is now named what we wanted it to be named. This sum n here is just counting the total number of observations and dividing it by the number of observations in that category. So this is actually what it is that we're printing out here. If you wanted to, for example, make that a percentage not added up to 1, you can just multiply it by 100, and that should give you a percentage there. But you don't have to do that. So moving on, we are also going to now create a histogram. Now, the histogram is corresponding to problem 1C, and it's a new function that actually is built into R, so we don't need to use any libraries or anything. And all you have to do is type hist, and then you type in what data you want. So in this case, we want income data from the vote DF. And the way we get that income data from the DF is to, here's the income right here. It's a column, so like a lot of the other functions, we want to just select one column by using this dollar function. And then once we have typed that and put that in the histogram function, we can also add a variety of other, we can also add a variety of other information to just make the histogram just look a little better. So we're adding a Y label. You can feel free to please type in the name, the actual proper name of the X label. You can add a Y label, and then you can add a title. So please, add your title here. Please change the titles, and then you can highlight the whole thing and try to run it. And what you'll notice is that you have successfully ran that histogram. Now, histograms can actually be exported pretty easily. What you'll notice is that the histogram showed up in the bottom right in the plots tab. And if you're interested to export whatever it is that you just printed, you can just export it, save it as a PNG or a JPEG or whatever, and then you should be able to put that into your assignment. The other way to do a histogram is to, again, use a different external library like we were using before with dplyr. So this one, you have to go through the same process. You have to either install packages and then put the name of that package inside it, which is ggplot, or you can go into the packages tab, install, and type in the name of that library and install it from there. So let's try to use that one this time, because we did the other method the last time. So like before, R is installing the package now, as it says right there. This will probably take a second. And below here, you can see that it says installing package. This little stop sign came up, which means that R is in the process of running something. So you just have to wait a second. It says it's installing the package, so that's a good sign. And it said the downloaded packages are in this folder, which means that you successfully installed it. But remember, you can't only install it, you also have to import it. And we do that by running the library function, and then in that function, you have to put the name of the library. Which is what we do there, and it looks like it's successfully imported. There is no errors. So unlike the histogram function, it's a little bit more complicated to plot, but we take the name of that data frame that we're accessing. So we put that little pipe operator again, like we were using before, and then we use the command ggplot, and in that ggplot command or function, we put AES. Don't ask why this is just how ggplot works. When you're putting data in, it's usually in this AES function. And then finally, we put in our data, which is the income column. So it's exactly like we were doing here, the income column, but we don't have to actually use this vote df and income together. We can just type income, and then we add this little plus, and this just adds the histogram portion of it. And if we run the whole thing, it should show something similar to our histogram plot. So for 2.22, don't feel free to not use ggplot because it's a bit more complicated, but I just wanted to show you another really commonly used package in R. Most people always use ggplot and dplyr on a regular, not always, but use it on a regular basis. So the next portion of the assignment that I want to show you is how to use summarize function, or how to get summary statistics, but actually you should be pretty familiar with this already. This corresponds to problem set 1E. Again, this is the summary function. You take the name of the data frame, you take a $sign, and then select the name of the column, and this will give you the summary statistic. But now I want to show you also how to do that in dplyr. If we wanted to do it for just one call, if we wanted to do the exact same process in 3.1, we just do the name of the data frame, pipe operator, select, which selects a certain column, and we want to select income. And then after that, another pipe operator, and we write the summary function. So this will give the exact same answer as 3.1, just in a different way. The last thing I wanted to do is to show you how to create summary statistics, but for different groups. So the first method we will use is the non-dplyr method. What we will do is get this mean function, and within that mean function, we're going to put the name of the data frame, the name of the column we're interested in, the name of the column that we're interested in, which is, in this example, income. And if we just simply run that, of course, we just get the mean for everybody. But if we wanted to get the mean for only women, or only one gender, we would put these little brackets here next to the income column that we selected. We would put the name of our data frame again, and then the column that we are selecting by. So in this, we're selecting by the gender. And if we wanted to get the income for only the people that were of gender 1, which I can't recall off the top of my head if it's male or female, but let's just say it's male, this would be how we write it. So it's the name of the column that we're interested in, that data, and then we group by the data that we put inside this right here, and then it will give us the mean for only those of gender or sex number 1. If we wanted to do the other sex, all we would have to do is type in 0 and it would work. So that's what this is here. And you would do the same thing for a standard deviation here. And that is how to do it. If we wanted to run both of those, we could put each in a new object here that we're creating. So female mean and female standard deviation for income. And we would be able to save those. And then if we wanted to put those into a table, we would use this function called cbind, which puts those together. And then we could create this new summary table that shows the mean and the standard deviation for each. Now, you can also do this in dplyr. You can write the name of the data frame followed by the pipe operator, and then you would actually be typing a new function called group by, and within that you would put sex, and then after that you would type another pipe operator and use this summarize function. In the summarize function, you can create new summary statistics, and these on the left side of the equal sign you can name whatever you want. And then within that, you say equals, and then we want to say, if we want to find the mean, we just use the mean function. And then within that mean function, we put whatever mean that we want for that column that we're interested in. So in this case, we're interested in income. And so we use that, we do that, and then you do a little comma if you want to see another one. You could do standard deviation equals the standard deviation function and the one in the column that we're interested in. And if we try to do this, it will give us the average weight and standard deviation for each of the sexes. So for sex 0, it would be 12 and 4, and for sex 1, it would be 11 and 4. Now, if you wanted to see not just income, but let's say we wanted to do education, all we would have to do is just replace that income with education, and we could see education. And it should work. But if we wanted to do that, we might want to say average education, whatnot. And the same can be said for this 4.1 example. If we wanted to see education, we could, for those that have education level 1, we could do the exact same thing. But I'm not going to do that right now. You can feel free to play around with it. That was today's lesson. Sorry that was kind of a lot to cover, but your problem set is due next week. Please let me know if you have any questions about importing the libraries or about anything from the first lesson. This is a lot to learn. If you don't understand it all, that's completely okay. My office hours will be Thursday at 2 p.m., so please come if you're interested to ask questions.